Today, let's solve a problem to see how a temperature changes the rate constant of a reaction. So, this is the problem we are considering today. The activation energy of a reaction is 65.8 kJ per mole. On changing the temperature from 2 degrees Celsius to 27 degrees Celsius, its rate constant changes by, we are given 3 options, A 11 times, B 5 times, C 8 times. So for the problems involving activation energy and the rate of reaction, the basic starting point is usually the Arrhenius equation. The Arrhenius equation is given by K equals A times e power minus Ea by RT, where K is the rate constant, A is the frequency factor. I already explained it in a previous video. Ea is the activation energy, R is the gas constant, and T is the temperature. Now we have to compare rate constant at two different temperatures. So we can write the ratio of the two rate constants in this expression here. Now what we can do is we can simplify the equation. Since we have both A in the numerator and denominator, we can just cancel them out, and then we will get an expression involving only the exponential parts. Now we can do some basic arithmetic using the exponentials, and we can rewrite the ratio K2 by K1 equals exponential of Ea by RT1 minus Ea by RT2. That expression can be further simplified or rewritten as K2 by K1 equals exponential of Ea by R times 1 by T1 minus 1 by T2. And you can take the LCM and rearrange it in this form if you like. Now we are also given some data and information in the question. The activation energy is given as 65.8 kilojoules. The temperature, initial temperature is 2 degrees Celsius, which we have to convert into Kelvin. So that would be 275 Kelvin. The second temperature is 27 degrees Celsius, which is equivalent to 300 Kelvin. And the gas constant R is 8.314 joule per mole per Kelvin. Now what we do is we can substitute all these values into the expression. Then we can do a basic calculation. If you have access to scientific calculators, it is fairly simple, and you can get a value which is approximately equal to 11. So to solve these kind of questions involving how the temperature change affects the rate constant, this is the expression you need to keep in mind. The ratio of the rate of reactions K2 by K1 is given by exponential of Ea, which is the activation energy, by R times 1 by T1 minus 1 by T2. And if you don't have access to scientific calculators, but instead you have access to log and anti-log tables, you can use the expression on the right, where we just take the logarithm, natural logarithm of the expression. So that will be log K2 by K1 will be Ea by R times 1 by T1 minus 1 by T2. So I hope you find this video helpful. If you like the video, please like and subscribe. See you next time.